AC fundamentals. To understand AC fundamentals, let us consider the waveform I am showing here. You can see the y-axis, there is a small e, that is the instantaneous voltage, and you can see in the x-axis omega t, there is the phase angle. Now this is the sinusoidal waveforms. Now at a particular point, the instantaneous voltage changes in the sinusoidal waveform. Then we can say this is the alternating voltage waveforms, and where you can see that EM is the maximum and minus EM is the minimum, and you can see that pi is the phase angle and 2 pi is the phase angle for a complete one cycle. Therefore, I am showing is a complete one cycle of n waveforms, and similar to the current waveforms also. Now, these waveforms can be expressed here. I am showing these waveforms can be expressed by these equations, because already I told I am considering the sinusoidal waveforms, and where is E is the instantaneous voltage and EM is the maximum voltage. It is also called amplitude, and where is omega is the angular velocity, and omega can be expressed by this 2 into pi f, whereas f is the frequency. Therefore, the equation number 1 can be written by this equation also. Therefore, this is another form of the equation, and we know that frequency is equal to reciprocal of time period. Therefore, the equation number 2 also can be written in these forms. These are the three different forms I have shown. This equation can be written. Now, another important in AC fundamentals is the phase difference. Now that we'll discuss now. Now you can see two sinusoidal waveforms I have drawn here. And if you notice that the dashed sinusoidal waveform, the maximum it is reaching before the solid, this maximum it is reaching before. And this is the, already I told, this is the phase angle. Therefore, what is the phase angle difference? Let us take in as a phi. Therefore, we call that the two waveforms, one is shown in the dashed line and the other is solid lines, have a phase difference of phi. And which is reaching before? Reaching before is the dashed line, the maximum it is reaching is before. Therefore, we call that the dashed, the sinusoidal waveform is ahead of, leading the other waveform, which is in the solid line. Therefore, if we represent the solid line with Em sine of omega t, then we will express the dashed sinusoidal waveform by another adding of angle phi with this. That is called the phase difference should be added. Now, another thing I have to mention here, that I given an example of finding the phase difference while which reaches the maximum value earlier. But it is a similar thing. It can be or for a which is crossing the zero earlier. That also can be on. This is the zero, and here I am showing the phi, which is crossing earlier, and that will be the leading. And there in this case here also you can see the phi is the phase difference. And this is all about the phase difference. Root mean square value. Now, root mean square value is an important concept for solving the AC problems. The root mean square value of an alternating current is given by the steady current which flows through a given resistance for a given time producing the same heat as produced by the alternating current when flows through the same resistance for the same period of time. Now, what does it mean? Let us consider there is a resistance here, the resistance R of a conductor, and the current flows through this is I, and I am just write that I am, it is a alternating current I, therefore sine omega t. And as a result, the heat produced on these resistances R is equal to H1. Now, same resistance, same resistance is R. Now, if I allow the DC current, steady current I, to flow through the same period of time T1, here it is time T1, same period of time T1, then if heat produced is H2, then if H1 and H2, both the heats for AC flow of current and DC flow of current, the heat produced is the same, then this steady current I will be called as RMS value of this alternating current. That is the interpretations. Now this is the same interpretations I am showing here. Here I am showing this is the resistances R, and a alternating current I is flowing through it for a time period of T, and another circuit I am showing that the same resistances are, and here now it is a steady current is flowing through it and producing the heat H2. Now if this H1 and H2 both are same, then I is the RMS value of I. That is all the definition. Now we can find it out that the relation between the steady current and the maximum value of Im, that is Im divided by root 2. That is, if it is I showed here that is the Im, that is Im divided by root 2, that is the maximum value of the alternating current. And in the similarly for a alternating voltage also. Now another concept is what is the average value? Average value of an alternating current is given by the steady current which transferred the same charge to a circuit as transferred by the alternating current during the period of time. Now if the alternating current is given by this expression, then we can find the relation between the average value and the DC current. Now you can see that average value is 2 into Im. Im is the maximum value divided by pi. Now another terms we should know that what is a form factor. Form factor denoted by Kf is the RMS value to the average value. Now we know that RMS value is maximum current divided by root 2 and average value is 2 Im divided by pi, and for a sinusoidal, that is an important thing for a sinusoidal. And then the form factor found to be 1.11 for sinusoidal alternating current. And all I am discussing here for sinusoidal waveform. Again and again I may not repeat the sinusoidal terms, but it is everything we'll be discussing for a sinusoidal waveforms. It may be a current or it may be a voltage.